Energy. It's everywhere in our lives, literally all around us. It's water flowing, fire burning, wind gusting. Energy can never be created or destroyed, only changed from one form to another. And one specific type of energy is used now more than ever before: electricity. Electricity is electrical energy, and it's constantly in our lives, at work, at home, even in our pockets as we go about our day. But what exactly is electricity? Some say it's power, or charge, or the excitement of electrons. All true statements, but paints a very incomplete picture of what electricity actually is. When we charge copper wire, like this, with electricity, what is actually happening? Well, today, ELTEK Labs is going to show you electricity using something you may remember from your childhood. Let's say that this represents a wire. Electrical wires conduct electricity, which is commonly measured in volts. If this wire is used to conduct electricity, then what do you think 1 volt of electricity would look like? That was representative of 1 volt of electricity, a single impulse of electrical energy. Notice how the energy wave went down and then came back. Now let's send 2 volts of electricity down the wire. That was 2 volts. You notice that it was twice as large as 1 volt. Twice the volts, twice the electrical energy. If you want to increase the electricity, you can increase the voltage, like you just saw, or you can increase the frequency. Here's 1 volt. Now here's 1 volt, twice as frequent. Another option to increase the electricity is to increase the current, or amperage. To do that, however, you can't simply raise the voltage or raise the frequency. You have to add more conductors. To get 2 amps, you need twice the wire. Here's 1 volt at 2 amps. This is 1 volt at 2 amps, twice the electricity a different way. You can see the flow of energy down the wire and back. This is representative of alternating current, or AC. Alternating current moves in a wavy or sinusoidal pattern. Now let's have a look at direct current, or DC. That was 1 volt of direct current. Direct current flows in one direction, unlike alternating current, which moves in the sinusoidal pattern. AC, DC. Electricity and the conductors of electrical energy are also affected by their surroundings. This wire will most likely be in contact with materials that will change how it carries electricity. We see here how when 1 volt is sent through the wire that it stops moving after a few moments. But when we raise the wire off of the surface, we see that the energy is retained by the wire much better. This is because the surface is no longer in contact with the wire, which was causing the energy to dissipate. It is much harder for energy to dissipate into the air than it is against a solid material. Of course, energy doesn't go anywhere, it simply changes form. In this case, it changes to heat energy and is carried away by the surface, or, much less efficiently, by the air. Much of the electrical industry deals with trying to keep electrical components insulated from one another, and how well those insulating materials maintain under different stresses. This demonstration has been of just one of the stressors, electrical stress, that those materials can come under. This is electrical energy, and now you have a better understanding of how electricity actually behaves.